This is an underground cable puller. It is manufactured by the Conduct International here at Mankato. It uses a 49 horsepower diesel engine, and the capacity of this puller is 5,000 pounds. This is the only two information I have available for this system, and all the other stuffs are kind of made up. I can't have all these design specifications. Anyway, the way this thing works is a diesel engine drives a pump, and this hydraulic pump drives two hydraulic motor that pulls 5,000 pounds. So, and I have this information. Probably even though they're made up, they will be very close to what they have in the actual system. And the calculations are of course the exact same. So it says that you have question number 1 is asking you have 2% loss between this engine and the pump. So what's the pump maximum power available to the pump? So 2% of 49 horsepower is, I calculated it 0.98. So the available to the pump is 49 minus 0.98, that's going to be 48.02 horsepower available to the pump. And then as you can see here, the pump develops about 650 psi, and you get about 640 loss. So here the answer would be 0.98 horsepower loss, and then the available to the pump is 48. It's not asking here, however, that would be 49 minus that loss that will be available to the pump. Now it is the loss between pump and it says the 10 psi loss between pump and the motor. So we can calculate the horsepower available at the motor. So you got loss here, you got a bunch of valves and everything, so that this loss comes from those valves, pipings and fittings. So if that is 10%, so we can simply say 10 psi loss, 10 by 650 times that 48.2, so which I calculated 47 point, get that number, 28 horsepower. So that is available to the motor. Now let's see what are the other questions here. Calculate both theoretical and actual flow produced by the pump if it doesn't have any leakage or slippage. So it says produced by the pump, so I know that the pump horsepower we have available to the pump. So power to the pump available is 48.02, and we can write power is PQ by 1714. We know the pressure developed by the pump, which is 650, I think, horsepower is equal to 650 psi times Q will be in gallon per minute, then the conversion factor will be 1714. So then Q is, I calculated 126.6 gallon per minute. So that's the answer for these questions. It's gonna be same both theoretical and actual because it says there is no leakage. Question number 4 say if no leakage between pump and motor, calculate theoretical and actual flow rate in each motor. So this flow is divided into two motors. So basically each motor will get half of it. So each motor will get 126.6 gallon per minute divided by 2. Remember, the pressure doesn't get splitted because it's the same line connected to the pump. So it's the flow that is splitted into 3 gallon per minute. And then it says at the highest engine power 49 horse, the underground cable puller pull its maximum capacity 5,000 only at a speed of this. Calculate the power input by the system. So that would be output by the system. So we can simply do P equal FV by 550. So I got 5,000 times 3.8 divided by 550. That is calculated 34.55 hertz. Overall efficiency of the system, so any eta is equal to that 34.55 divided by 49, I got that 70.5%. So it says that most of the loss, so the cables are routed using 3 pulleys. I'll show you what those pulleys are. So this is pulley number 1, and they got couple of pulleys here so that it can smoothly run it. So most of the losses occurs in the pulley friction with the drum. So it says cable is routed to the 3 pulleys, smooth operation if there is no loss between motor and the pulley shaft, calculate the power input. So at this point, so here you got the motor, and then this is why this coming, how much power is coming here. So that is 34.55. We have calculated that. And then what's so there is no calculation for this question. Basically you can just use that from the earlier. And most of the loss occurs in this pulley, blah blah blah, calculate total power loss in the pulley. So we know that the motor gets about 47.28, and then the final output power is this. So I have got 14 point, didn't calculate that one. Let me calculate that. So 47.28 minus 7.28 minus 34.55. So I got 12.73 horsepower that is lost in the pulley friction and everything. I think that's all for this question.